Does it look all right? Okay, perfect. So I should warn you before I get started, this title is a big fat lie. I thought I would write about my experience working with Elm on a side project that's grown to, it's not a huge application, but a reasonably sized application. But honestly, the only lesson I've learned is I love Elm and I don't want to use anything else to build UIs. And I also realized I was going to speak in front of Scala developers who might not have even heard of Elm before. So maybe I should try and do instead of, well, what it turned into, which is really a shameless sales pitch for Elm, for why you should use Elm rather than a more advanced talk that assumes some prior knowledge into the language. So who is this talk for? Well, I think I've just given you the answer. There's a lot of really good Elm talks out there, but most of them are really, they're aimed at JavaScript developers, right? And so the core argument of all these talks is what you see on that slide is undefined is not a function, sucks. So let's have compile time errors instead. And then the talk proceeds to tell you why strong typing is great and why function purity is nice as well and all of this. I assume that I'm preaching to the converted here and that I don't need to tell you why compile time errors are better than runtime errors. So instead, we'll focus on the rest of it. So the person I had in mind for this talk is probably more of a backend developer with experience in at least one FP language, could be Scala, Haskell, OCaml, something like this, with little to no UI development experience. So I will try and make this, I will try to assume no prior knowledge and explain even things that might seem fairly basic to a UI developer. So hopefully everyone is on the same page. And the last thing that I had in mind is, well, someone like myself, who wants a language that they can become productive in quickly. So I don't want to spend 6 months learning about the whole JavaScript ecosystem, and given the speed at which the JavaScript ecosystem moves anyway, in 6 months, whatever I've learned is probably already out of date anyway. So I need something that I can become productive with in a matter of days, not weeks, without compromising my project scalability. So I don't want to pick a language which, as the project grows bigger, as there's more and more lines of code, where I risk reaching a point where I'm constrained to rewrite the whole thing in a different language because it doesn't scale too well. And then the other thing that I meant by scalability here is how easily can I find people to bring onto the project if I need to later on. So either it has to be a language that already has a lot of people, work with. So React in that sense would be okay. Or a language that's super easy to learn, once again. So I can pick virtually any developer and they should be able to learn it in a few days. So what is Elm? It's, that's how I would define it. It's a strongly typed, purely functional DSL for building browser-based applications. So if we try and unpack that, strongly typed and purely functional, this is an example of Elm syntax. If you've worked with Haskell before, that probably looks very, very familiar to you. And you may recognize something that you've seen in other languages. We have ADTs, so you have an example of a sum type right there. We have pattern matching, down there with exhaustive checks out of the box. We have function currying. So when you look at a function signature right here, basically all the types except the last one are the types of input parameters, except for the last one. The last one is the return type, right? So everything is curried by default. And of course, functions are first-class construct. You can pass them around to other functions and so on and so forth. One thing I love about this language as well is how compact it is. Again, this is an example how you do the same thing in Scala versus in Elm. We tend to think of Scala as a fairly compact language because we compare it to Java, but you can do even better than that. And frankly, to me, the less character there are on the screen, the better, right? It's less clutter to look at. And then the second thing about Elm is it's a DSL for building browser-based applications. So it is not a general-purpose programming language. You will find people that have tried and pushed the boundary a little bit. So you will find a library that someone wrote to run Elm code inside AWS Lambda functions. There's another talk as well on YouTube of someone who runs Elm on a robot. So I don't know how he's managed to do that, but really you're going to have to write a lot of boilerplate and you're kind of going against the grain if you try and do something like that. It's not been designed to do anything else than building browser-based UIs, really. The language is built with the idea that it's going to do only one thing, and it's going to do it really, really well. But that's it. It doesn't try to cater to every possible need. As everything that runs into the browser, at some point you have to spit out some JavaScript. So this is how it works. You'd build an Elm project, which you can split, across multiple modules, multiple Elm files. You run this through the compiler, and out come a really ugly, giant file of JavaScript. And all you have to do is you have to import this JavaScript into an HTML file, and then you point your browser to that HTML file, and there you go. That's your application. The HTML file is, pretty straightforward. So you would import this little thing that I've called app.js here, which is what the Elm compiler will spit out. And as you do if you've used React, if you've used Vue, it's the same process. Inside the body of your HTML file, you have to create a div onto which you're going to mount the app. So you create this div, and then you add a little script where you just invoke the entry point of your Elm application and mount that on the app div. And that's it, really. That's all there is to do, aside from Elm code, to get an Elm application. Now, Elm is designed to build what is known as single-page applications. So if you go back maybe 15 years ago, UIs were typically rendered on the server, right? So you sent a request, and then the server would render an entire HTML page, send that back to you, and if you interacted with the page and some content needed to be refreshed, again, the server would give you an entire new page, and it's not ideal. It doesn't make for a very fluid user experience. You have that split second, even with a good connection, even with fast server, where your screen just goes blank while the new page is loaded. So for the past maybe 10, 15 years, we've had what is known as single-page applications, where you load a big JavaScript file when you first access the website. And effectively, as you interact with the application, the only thing that gets re-rendered are a few components on the DOM. You do not re-render the entire page. And the only thing you fetch from the server is typically some JSON payload, right? Again, you don't fetch fully rendered HTML typically. And there's two things that matters when it comes to this kind of application in terms of performance. The first thing is the initial JS file you need to download should be as small as possible. Right? The bigger it is, the longer your user is going to wait for the initial payload. And the size of that file depends on, well, A, the complexity of your code, but also the complexity of everything it depends on. So one thing that's great is to have a framework that's as small as possible, right? So you reduce the size of that file. This is a benchmark of Elm versus popular front-end framework. It doesn't really matter whether Elm is the very top one or not here. All you want to make sure of is that you don't pick up a framework that's maybe at the tail end, right? You want to make sure you're not going to run eventually into some problems with your application becoming too big. And Elm seems to be faring pretty well here, just a little bit better than Vue and better than some combinations of React and other stuff. And then the second thing that matters is how quickly can you update the DOM. Once you've loaded that initial application, once your users start interacting with the page, how quickly does the page change in response to the user clicking around? And again, Elm is doing really well on that point. Yeah, like the difference is not as marked in this one, but yeah, not something to worry about. Definitely better than most of the mainstream frameworks like Vue, Angular, React, and so on. Okay. One thing that some of you might have, one question that some of you might ask if you have Googled a little bit Elm before coming to this talk is Elm actually still a thing in 2024? And I think the main thing prompting this question is the last Elm compiler release is almost 5 years old now. And I would argue that's actually fine. There's a number of reasons for that. Part of it is just because of how Elm is developed, and part of it is just a sign of maturity. So if you look through the history of Elm releases, obviously, as time goes by, there's fewer and fewer of these releases, and now we seem to have reached a point where you can build pretty much anything you could think of in a UI with Elm, so there's not really any need for new, at least new compiler releases. Someone even went through the trouble of creating a website for this, iselmdead.info. And it will explain much better than I can why no, Elm is not dead. So check this out if you want a more detailed answer to that. One thing to note is the Elm community is very, very active. So you will get new packages every week. There's a website where all the new packages releases are aggregated. So it's still very, very much, very, very active, and people are building new things on top of Elm. So one thing I came across recently is Elm Pages, which allows you now to do server-side rendering and static websites, which was not a thing when Elm first came around. So yeah, there's lots of awesome packages being released all the time. Another reason why we haven't seen too many releases of the Elm compiler is, so part of it is there's a single person, this guy, that is responsible for designing Elm, right? Elm doesn't have a big corporate backup. It doesn't even have an academic backup. So unlike most languages where you have a team, usually of at least half a dozen people working on a language, here it's just this one guy. And he also prefers to work, like there's a really good talk here that I've linked. There'll be a QR code at the end of the presentation if you want to go to the slide and watch this talk. But he also explains that in some languages, the releases go as follows. So someone will raise an issue, and then the language maintainers will patch that issue. And then someone will raise another issue that's maybe slightly related to the first one, and there's another patch. And you imagine there's this like very noisy convergence towards a good solution to that issue. Whereas Evan, the creator of Elm, doesn't like to work this way. He's like, I prefer to wait for a little while, let people raise issues, and then I kind of clusters these issues, see the ones that are related to one another. And once I've got, I get a sense of what the problem might be from all these issues, I like to list out all the possible solutions and weight the pros and cons. And only when I'm convinced I have found the proper solution do I actually include it in the language. Not before that. So it's also by choice that that releases are few and far between. And then the last thing is, we're talking about front end. I think React has won over the space. It's really a winner-takes-all environment. So, you can't expect anything other. You can't expect any other framework, anything else, to have the same pace, of releases and the same amount of package as React, really. So anything else you pick that is on React is, you're going to see something like that. Okay, so what makes Elm so special? I think, to me, it really boils down to that, is Elm was designed with developer happiness in mind. If some of you are old enough to remember Ruby on Rails, that's another one that was designed with developer happiness in mind. And I think that's a really, really great thing about the language. So the first way this is manifested is Elm is super easy to learn. Like, you can learn the whole language syntax in a couple of hours maximum. There's really good documentation on the website. It's really stripped down. So there's a lot of things you'll encounter in other FP languages, like high, kindly type classes, all that. There's none of that in Elm. And it's not that Evan never wants to bring those. It's until there's really good reason to do that, we're not going to bring them, because it just adds complexity. And the payoff for this is, it's not too great. Oh, sorry, what's happening? Display will be turned off in 1 minute. Okay, well, I don't know where Rory is. Well, let's keep going. And the other thing is it comes with batteries included. So these are the different frameworks that I tried before settling on Elm. So years and years ago, I tried Vue.js, and if I had to write JavaScript, to be honest, that would still be my favorite framework. Vue.js is pretty decent. I tried Scala.js back when it was in the Stone Ages, so my assessment of it is probably not very fair. I think some awesome frameworks these days, like there's Tyrion, which I think Dave maintained, there's Laminar, and so on. Back when I tried it, you had to bring in React. And so for me, that wasn't, there's a steep learning curve to Scala, and then you have to learn React on top of it. And so I thought, if I ever need to bring someone else onto that project, that's not a super great choice. And the last thing I tried was Next.js, which is, it's React with a few things like alter, server-side rendering. And again, it's similar to Vue. It's okay, but you're still working with JavaScript. And you still have the following problem, which is if you want to set up a JavaScript project, you need to pick a package management tool. So NPM or Yarn. Then you need something to update the virtual DOM, right? So you pick React or you pick Vue. Then because JavaScript is super brittle, what you'll see most UI developers do is they have a dev server so that, okay. Sorry, we have it slight. Okay, should I keep going with that one? Oh, sorry.
Right, I'm either going to turn all of it. Hey!
Awesome.
Don't think I touched anything.
That's fine. So what you'll see a lot of UI developers do is on one screen, they'll have the application actually running, and on the other one, they edit the application. Because with JavaScript, you can't, as Scala developers, we're used to making 10 changes into our app, and then we just follow the compiler, and we know that when the compiler is happy, at least the application is not going to explode at runtime, ideally. The business logic might not be correct, but we can have that confidence. The application will probably not throw runtime errors. There's none of that in JavaScript. You change 10 things in your editor, and suddenly you have the white screen of death when you suddenly return to your application. So you need that if you're going to create a JavaScript application. And then you need state management, because frameworks like React and Vue, when they initially started, you have this concept of component. So a component is a small bit of your UI, maybe a button, maybe a menu, something like that, and components are nested within one another. And they communicate with one another. The parents component can pass props to the children component, and then the children can emit events that can be called by the parents. And you can imagine as you grow, well, each component can encapsulate a state, similar to an object if you've done OP. And the big problem with that is, of course, as you add more and more components to your application, well, the number of possible interaction is going to grow with the square of the number of that component. So very quickly, it's a complete mess. It's unmanageable. So you need to bring in something like Redux or Vuex, and then you need strong typing. So you bring in TypeScript flow, and I think you can see where this is going, right? Before you've even gotten started, you need to put all these things together to have even something like a Hello World application. The solution that the JavaScript community has found to that is to give you command line applications. So there's a create React app, and there's a create Vue app, and so on, command line applications where you can configure an entire project and it generates it for you, which personally I'm not a big fan of, because I don't know exactly what it's doing behind the scenes, right? It's pretty magical, and if I ever need to change something in a project, I have no idea what to touch, where to change things. So I don't like this. Ideally, I want a language where everything is included, and Elm does exactly that. Right? You install Elm, you have the package manager. The DOM updates are baked into the language, so it's both a language and a framework, really. Hot reload, there is an Elm reactor command that allows you to do that. You don't really need it, just trust the compiler. If it compiles, it probably works. State management is baked in, strong typing is baked in, and so on and so forth. So you have everything with Elm. You don't need to fiddle with all these different options, all these different tools. Okay, so just to give you a feel of what building an Elm app is like, I'm going to show you a very, very simple example. If I wanted, well, we're going to use an existing project to make it simpler. But effectively, if I wanted to create a new Elm application, all I'd have to do is create a new folder, cd to that folder, and then I just go Elm init. And that would create the basic setup for my application, which would contain the following. There's an elm.json where all the dependencies are managed. And then the thing I would add that you have to add manually at the moment, which is the HTML that we just discussed, right? So you import your Elm application in it, you mount it on a div, and that's all you need to do. So let's look at a simple Elm program. The entry point to every Elm program has to be called main, and it has to have the following signature. We'll look at it more in a moment, but basically it needs to have the type program. Take some flags in this example. The flags are nothing. Flags are configuration that you can pass at the start of your program. So for example, the URL to your server, if you needed to talk to a server, you would pass that with the flags. A model, which is an immutable data structure that represents the state of your application. And then messages, which are emitted as a result of the user taking some action in your application, and are passed to the Elm runtime to update the application. So that is our entry point. Our model, in this case, it's a very simple counter application, actually. Let me show you the application before we get started. It's something like that. Right? It's the most basic thing you could think of. Just a little counter like this. So our model, we can just use a type alias integer. It's good enough with initial value of 0. Message, so yeah, that's the thing. As the user interacts with the application, that's the thing that gets passed to the Elm runtime. And then your state is updated in response to these messages being emitted. So here we just have two. We have increment, decrement. Then you need the update function to actually update your state in response to these messages. So the signature of that is you receive a message, you receive the current state of the application, and you have to return the updated state. So depending on whether we increment, decrement, we do the right thing here. And the last thing you need is a view, which is to, well, you have a model. how do you want that display on the page, right? So you take in a model and you return some HTML that is capable of emitting messages as the user interacts with it. It's pretty straightforward. You have these, the constructor for different HTML tags. The name is pretty obvious. So yeah, hopefully that's easy enough to pass. And that's it. That's a simple Elm program. That's all you need to do. So if you try and make a small change to this program, for example, if we try and add a reset button, I'm going to add another kind of message here to allow resetting. And immediately, you can see I'm getting an error message. The Elm compiler has realized, okay, you are not, the checks are not exhaustive here in your pattern match. You forgot to handle the reset case. So immediately, it's picked that up. So if we do that, now the compiler should be happy. There's one more thing we need to do, which is that we should add a button to actually allow us to emit this message. So we're just going to add a little reset button. And we're going to say, oh yeah, when you have, so all of these constructor that, all of these methods that take the name of an HTML div, that's to construct that particular HTML element. And then it takes two lists of arguments. The first one is for HTML attributes, things like the CSS class that you might want to give it, what happens when the user takes a particular action when they click, for example, on that particular element. And then the second one are the children of that element. So in this case, yeah, just some text. All right, and on click here, we want to reset. And hopefully that should be correct. So if I now go here and try and compile it, yeah, just run this through the compiler. Seems happy. And there you go. Right, so that's how simple yeah, it is to build a little Elm program. All right. One thing about Elm is even though the language itself never became really mainstream, it's still a bit of a niche language. It has a huge influence on other languages and frameworks. So you may have heard that Elm was one of the main influences behind Redux. In Redux, you have this idea of reducer. So again, pretty soon people realize that it's not a great idea to have every component in the UI encapsulate their own state. It's better to represent the state as one single immutable object that is then modified by emitting certain actions. And that's the signature of reducer in Redux. So you have this function that takes a state, that takes an action and returns a new updated state. And that is exactly the signature of the update method that we saw in Elm. That's exactly the same thing. The other thing that Elm is well known for is how friendly its compiler is. It was probably one of the very first languages to have a compiler that actually doesn't just throw a stack trace at you, but actually tries to give you some hint and tell you what might have gone wrong and how you want to fix it. So here's a couple of examples of compiler error messages. Sometimes it's, you could probably figure it out on its own, but sometimes the errors are actually really helpful. So in this case, don't know how well we can read that, but in this case, the user has tried to define a type that actually has infinite recursion in it, and the compiler, like that's not something that's super easy to find. When you hit that kind of error, if the compiler just doesn't tell you what's going on, it's not always easy to figure it out. And here the compiler very helpfully suggests what to do instead to fix this problem. The other thing the compiler does is because you have static typing, for example, if you're releasing a library, it can enforce proper semantic versioning, so it can detect whether you've changed the signature of public method and tell you, well, actually, no, this has to be a major release. Right? You can't release that as patch or minor change. It's influenced languages such as Rust. So there's an article here from the Rust blog where they explain that they looked at Elm to try and make the compiler error more friendly. I believe the team working on Scala free compiler as well has looked at Elm for inspiration. I couldn't find the exact blog post explaining that, but I believe they've also looked at it. Okay, so what is it like to actually build and maintain a medium-sized Elm application? I mean, it's awesome, but let's have a look in a bit more detail. The development environment is pretty simple to set up. I use VS Code, and there's a great extension for it. So it does everything, syntax highlighting, go-to definition, everything that you might need. The only slight issue that I've had with that is when your project grows quite large, sometimes you need to close close VS Code and reopen it again. It never quite, once you reopen it, it's fine, but sometimes it gets stuck. It gets stuck to a point and go to definition, stops working, but just, turn it off and on again, and it will work. It will work again. So not a big blocker here. Okay, then there is this concept of Elm architecture. So the thing with Elm is all the functions that you are going to write, they have to be pure function, right? It's a purely functional language. You're not allowed to have any side effects. All the side effects are performed by the Elm runtime. You're not allowed to do that yourself. And so you need to provide certain functions to your Elm program that meet predefined signatures. So the entry point, as we've just seen, to an Elm program, it has to be a main value of the following type. So a program with flags, which we use for config, model, and message type. And you construct such value using methods from a special package, which is called a browser package. And there's a few different methods you could use from there. The sandbox one that we've just used is the simplest one. When you don't need to speak to the outside world, that's what you'd use. There's the element one, which is the one I find myself using most of the time. So this supports, external calls like, this supports talking to the outside world, like JavaScript. So if you want to make HTTP calls, if you want to get information from the browser, you can do all that. And then the next two are not super useful. Document is it's the same thing as elements, just you can also adjust the title of your page. Not super useful. Application is if you want to create, if you want to have like dynamic routing. So you actually want your application to pass information from the routes. For example, you have a URL that's like /user/ID, and you want your application to be able to extract that user ID. I don't like using this simply because when you release the application, then you need to actually have an HTTP server to run the application, right? Because you need to be able to pass that URL. Whereas if you just use element, you compile your JavaScript, and then you just upload that to an S3 bucket, and your code is deployed. You don't need to run anything. Just drop it into an S3 bucket, and it's in production. I find that a lot simpler. So I prefer to do that. But if you wanted to actually have proper dynamic routing, you could do that. And yeah, this is the signature that we just saw in the counter application example. Pretty simple. You have to give the initial state of your application. You have to tell the application how that state is to be rendered into HTML. And then the last thing is you have to tell it, okay, in response to user actions, how do you update the state? If you want to use browser element, which is the one that I use most of the time, the signature is just a tiny bit more complicated. But you have the option of passing some initial configuration, as well as executing an action as the first state is loaded. So everything that you see here that has the prefix command, these are messages sent from Elm to the outside world. So for example, making an HTTP request. So you can imagine if I had a news website, for example, upon the page loading, I would probably want to call an API to get the latest news. So that's how you'd use that. Vue remains unchanged. The only thing that changes with update is, again, you have that possibility of talking to the outside world if you want to. So in response to a user clicking a button, you can, again, send an HTTP request. And the last thing is subscription. That's information coming from the outside world inside your Elm application. So for instance, if you wanted to detect the language used by the browser, so you can change the language in that page, that's what you would use. You'd use subscription for that. And so command and subscription really just denotes asynchronous exchange of messages between the Elm runtime and the outside world, i.e. JavaScript. And this is an example of how, so these are purely asynchronous exchanges of messages. So there's no guarantee, for example, when you issue a command that you'll get a subscription back. You could issue lots of commands and never get anything back. Similarly, you could have subscription coming in without you actually have issued any command. So for example, fetching the browser language, you don't need to issue a command to get this information from a subscription. So in order to handle HTTP requests, where normally you'd issue a command, you'd send a request and then you'd receive a response, there's a very helpful HTTP package that's been put together here by the Elm team that effectively is built on top of those commands and subscription, but allows you to map one-to-one, one request to one response. So this is how you would make a call to the outside world. All you need to do is you need to define two types of messages. one which is actually send a request, and the other is how you're going to handle the response, right? And as the response arrives, this message is automatically, like the update function will be called with that message automatically for you. So all you need to do is then handle the result that you're given back, right? One important point as well is JavaScript interrupt. So there's still things for which you might need to rely on JavaScript. For example, WebSocket, you need to rely on JavaScript. So to do that, Elm has ports. There's no such thing as foreign function interface. You need to use ports. They're pretty easy to define. So here's a simple example. If I need to define two types of ports here to connect to WebSocket. One's an outgoing port. So from my application, I'm going to connect to the WebSocket. So you can imagine a signature like this one where you pass the URL, and then you get you issue a command as you connect to the WebSocket. And then a second message where you receive a second port that you're going to use to receive messages, incoming messages onto your WebSocket. And a signature like this one where you have to be able to convert the information that comes into these messages as in the form of a string to some message in your Elm application. Right? And this is how the same thing, I mean, this is maybe a little bit into the weeds, but this is how the same thing looks on the JavaScript side. So you not only need to write the port in Elm, you then need to add this. You can add it inside your HTML file, right? You can add a little JavaScript script here, but yeah, you need to have that to be able to, well, perform whatever action you want to perform in JavaScript. I use this, for example, there's one application that I built where I needed to use leaflet.js, and I didn't know an Elm equivalent, so I used ports to use a JavaScript library. In general, it's best not to rely on JavaScript if you can, because obviously whatever happened in JavaScript's land, exceptions and whatnot. Elm has no control over that. But if you really want to, you can fairly easily interop with JavaScript. The most dreaded thing for any backend developer, if you need to work with the UI, CSS. There is an Elm CSS package, very similar to the Elm HTML package. So yeah, you can, this is how you can add CSS to your view. Honestly, don't do it. I use CSS frameworks. You can use Bootstrapped. I like Bulma. It's my favorite. But yeah, just don't bother with it. All you need to do is you need to add a little something like that to your HTML documents to actually import the CSS style sheet, and you're done with it. Yeah, I wouldn't bother with that unless you eventually want to become, a proficient UI developer. You aim to get a full-time job. Just don't even try CSS. So if you add something like Bulma, all you need to do then to style your element is you use that class thing, which is standard part of the Elm HTML package. You add the class attribute, and then you, as a string, you add whatever Bulma class you want to use to style your element, and that's it, you're done with it. So in conclusion, why should you learn Elm? The first thing is it's a very low investment. Right? It's not a language that's going to take you 6 months to learn. It's going to take you at a leisurely pace, maybe 1 weekend to learn the language and 1 weekend to build an application and really get a feel for what it's like to work with it. So worst case scenario, you hate it and you've lost a couple of weekends. Like, it's not, yeah, it's a fairly low investment. It's worth the try. It's a great entry point into UI development if you don't want to bother with JavaScript. Yeah, and if you don't want to spend 6 months learning about React and all the various libraries you need to bring in to build a React project. For me, it's the lowest entry point into UI development for someone who already knows FP and knows some backend development. And then the last thing is it will make you a better developer. So if you're still fairly new to Scala, for example, still fairly new to FP, and you sometimes find yourself resorting to option, calling .get on an option or .head on a list or stuff like that, you can't do it in Elm. Right? There's no choice. You will have to learn to do things the proper way. And even if you never use Elm, just having to do things the proper functional way will make you a better Scala developer, for instance. So just for that, it is worth it. Why should you not learn Elm? If you want to find a job, it's useless. If you know any company that writes Elm and is hiring, let me know, but I don't know of any, and they're really, really hard to come by. Yeah, so learn React if you want to get a job. But that's it. Any questions?
Don't say learn React if you want to get a job. That's a horrible, horrible thought.
Sorry, I couldn't stop myself. Right, questions? Anybody?
Thank you very much for the talk and the presentation. So I was going to ask, you were showing that the basic model of Elm, the basic model of the program is a couple of functions from model to message. Is that correct?
Sorry, come again? The function is?
The basic model of Elm of a program is a couple of functions, right? Model to Elm to render it all. You were mentioning scalability. How scalable is it? How effective is it? Does it have a way to store things, or does it have to? It's a function, right?
Yeah. Oh, you mean how scalable, like, well, in terms of performance, or like in terms of how much code you have to write, or?
How well does it scale with load and so on?
With load?
The performance of the code.
I haven't hit any particular, I mean, my application is not huge, but I haven't hit or I haven't heard of, watching Elm talks. I think there's a company called NoReading. There's 300,000 lines of code of Elm. And I haven't heard of them hitting particular performance problem. I don't know exactly how it's done under the hood.
What's the name, sorry?
NoReading. It's an American company, and they use, Elm for all of their front end. So in terms of performance, I haven't heard of anyone hitting a particular blocker. In terms of, obviously, how much code, you probably will get started with something like that with just one file, but obviously you'll want to split that up, as you go. And that's perfect. That's perfectly possible. Elm supports modules and whatnot, so it's fairly easy to split the code as you grow the code base. But yeah.
Thank you very much.
Any more? Go.
So with this model update view way of going about things, can you split an app horizontally? Like, can you compose them into bigger apps, if that makes sense? Like, can you have, this is a model view update particular to this side of the app, but then... Yeah.
You could do that. Yeah, you could have, like, if you had two... So yeah, absolutely. You can have, separate state for separate components in your application, which is actually the first thing I did the first time I tried writing an Elm application. Unless you have a really good reason for it, I would recommend avoiding it, because again, you find yourself in that situation with components that sometimes it's very rare that you have an application where the components are completely separate. They'll need to talk at some point, and then you find yourself against passing events up to the parent and down to the child. I really would try and stick to the one global state if I can, but if you really want to, yeah, it's possible. Absolutely, and it's quite common, I think, when people don't build the project with Elm from scratch, when they start with a React project, and then a few components in that project are Elm, right? When they try and introduce Elm progressively into a JavaScript project, I think people find themselves doing that. But
thanks.
Yeah.
Any more? Yes.
Hiya.
Hey.
I love the Elm architecture, don't worry, it's an easy question. One thing you didn't talk about at all was the other kind of scaling. So Diego's question was about scaling performance, but do you have any comments on how you actually scale? I mean, these are clearly functions, so function composition should just work, but does that work if you want to scale to a really big app?
Yeah.
Any pro tips?
Any pro tips? There's a really good talk by a guy called Richard Feldman that wrote one of the Elm books. I can give you the name, after the talk if interested. But yeah, where basically he explains, well, just you can use function composition, and so effectively, instead of having a giant views with giant view function with 10,000 lines of code, you might want to define individual function for how do you render a button, how do you render smaller things, and you can even move that code out into separate modules so it's not in the way when you're looking at your main entry point. So yeah, just function composition essentially.
Two. Oh, three.
I think if at all a question, you mentioned that for React the raw framework works to manage state, right? And how Elm manages the state, how Elm solves this problem?
Right, so Elm manages it the way Redux would do it. So you have one centralized state, which you are not allowed to manually mutate. You can't mutate it yourself. The Elm runtime will mutate it in response to messages, in this case, that are emitted as the user interacts with the application. Right, so that's how you manage it. Does that? answer your question, or?
But then there should be some frameworks to manage messages. Oh,
So that's what the Elm runtime does. So in this case,
I mean, when we have, let's say, thousands of different messages, they need to be somehow organized.
I mean, I suppose you can split down messages. So again, you can have, as you define, the message type, you can have, how do you say? You can use ADT, so you can use some types, right? So you instead of having maybe 100 different messages, right? So typically you'll define your message as a sum type, and it can be one of a bunch of things. So the same way we've done here, we've defined, here there's 3 possible options. Instead of just adding more and more and more and then reaching maybe 100 different messages, again, you can define a type here. Yeah, so here I'm going to define a new kind of message, and I'm going to say, I don't know, I'm not very creative with name, but that message can be a bunch of things. And I can shift that other message into a different module. And here I'm just going to say we have other message. Like, hopefully that makes sense, right? So you move that thing out of the way, and you see you can build like a hierarchy of message. Yeah, that's how I'd approach it.
Oh, there was a question in the middle here.
Yeah, thanks for the talk. I actually used Elm quite a bit at university a few years ago.
Oh, nice.
And it was absolutely lovely. I think everything you've said is true. But I found that as I was getting into more complicated things, I just felt like I was being railroaded basically by what Evan wanted me to do. And I was wondering, A, if you've experienced that, and B, how you think things will develop, like going into the future with Elm, and yeah, what that looks like.
Right. So I know he made a few very so at the time when we went from Elm 18 to Elm 19, I think he made a bunch of very controversial decisions. Like he decided, well, we're not going to have custom operators anymore. Screw you, everything. You can't do that anymore. Like he's really minimized the language, and I haven't found that to be a problem. There's one thing, however, that he did, which I have a problem with, which is the datetime library. Right? He's decided POSIX is the only acceptable form of datetime, right? And coming from Scala with a library like JavaTime, yeah, I miss local date, I miss all that stuff, all that good stuff is not there. That's the only one, I would say, part of the language where I found myself really constrained, and I would have hoped that the standard library would have a better solution. There are some libraries written by the community that are a little bit better. But yeah, for me, datetime is something that has to be part of the standard library. It's not really something you should leave to the community. So that's maybe the one thing that I found that, yeah, held me back a little bit.
There was one somewhere.
Yeah, thanks again for the tour. It was fun. So you said all functions in Elm have to be pure. So does it have like opinions on how it does things like dealing with the database and things like that? It must have a...
No. So, well, there might be libraries to do that, but yeah, I don't think it has particular opinions on that. Like I've only ever used, whenever I talk to the outside world, to me it's talking to a server, so sending an HTTP request, getting back some JSON.
So everything has to be kind of turned into JSON somewhere else in the back end, and
that's how I've used it. I mean, I suppose there's alternatives, but that's how I've used it. Yeah.
One more quick question as well. You mentioned it doesn't have type classes. I'm thinking in like
yeah, no type classes.
Why is that? What was the Evan kind of genius behind that?
So I think his argument was you're opening a whole can of worm, right? You bring a whole lot of complexity, and he wasn't sure there's any. It can't be justified, right? It's going to make the language a lot harder to learn because suddenly now people need to know what a monad is, what a functor is, and all that. And he's not really sure it helps with the developer experience. So yeah, obviously the trade-off is so map has to be defined for list and maybe and whatnot separately. There's no generic way to define what a map is. Yeah, he seems to think that's an acceptable trade-off. As far as I know, he hasn't completely rolled it out, but it's like until we have a really good reason, we're not going to bring that in.
Thank you.
No type class, no higher kinded type, yeah.
Could you define map as a generic function with like type parameters? instead?
With type parameters.
As in like,
with type parameters, yes.
uh,
But you
never
have to
mind.
define
Yeah,
it.
yeah,
Is it
yes.
on a list? Is it on a
Yeah,
maybe? Right?
yeah.
You can't abstract over
Yeah.
that bit.
Okay. The other question I had is, what is Elm written in?
It's written in Haskell. So the compiler
Okay.
is in
Okay.
Haskell.
Okay, thanks.
Right, one last question.
Sorry, thank you. Just quick information. If it doesn't have type classes, even normal ones, how does it solve the operator overloading of plus, equals, symbolic operators, and so on?
Sorry, come again. I'm not sure I quite understand how does it solve the...
Type classes were added to Haskell to solve the problem of how to have the equals operator for many types.
Oh yeah, you
But
have to
not-
re-implement it for every type. There's no way to define it just once. So you have to define equal for, every type you want to use it on. Yeah.
Right, a big round of applause for Sophie.